Good morning, dear student. Today we will teach about the center of mass of a system, why we needed center of mass of system in physics, and what is the importance of center of mass. The concept of center of mass arises when we use a system when there are two particles. For example, this is particle A and another is particle B, and the line along with they are attached to each other, and in free space if both are rotate along z axis, in this case it is difficult to solve the problems by concept of considering each mass of system. So we adopt a term which includes the resultant mass of m1 and m2, that is called the reduced mass. So let's consider it here. We have a systems in 2D. There are the two particles m1 and m2, and the radius of their from this axis along with they are rotate r1 and r2, r1 for m1 and r2 for m2. They are moving with the same angular velocity. So here the distance, the total r equal to r1 plus r2, and the center of mass of system, as we know that m1 r1 summation of mi ri always equals to 0. So after solving this we have these conditions m1 r1 equal to m2 r2, or we can say that r equal to r1 plus r2, where r1 is distance of here it is a slightly changed that it is not small r, it is the capital R. So here we can see that the r1 and r2 are the resultant distance of moving particles with this rotational axis. So the total kinetic energy of system will be equal to that kinetic energy of first particles and kinetic energy of second particle. So T equal to T1 plus T2. Now T1 equal to, as we know that in rotational motion the kinetic energy equal to half I omega square, here I1 omega square, plus T2 equal to half I2 omega square. Now taking the common factor which is omega square, we have resulted total kinetic energy T equal to half I omega square, where I equal to the resulted moment of inertia of system. As we know that what will be the total moment of inertia of system equal to I1 plus I2 equal to m1 r1 square plus m2 r2 square equal to, this further can be reduced in this term by applying a concept that we includes a term mu equal to, which is the reduced mass factor m1 m2 upon m1 plus m2. So by applying this constant mu, we can further write in this form I equal to mu r square, whereas you know what is the r is as we know earlier. So substitute this value we have in rotational kinetic energy equal to the total kinetic energy and further it can be written t equal to t equal to t equal to I omega square upon 2, where I we have the value of what is the I is the nothing but that this term, and we can change the I L equal to I omega. So by multiplying upper and both side we can substitute I in the term of angular momentum L. So this is the total kinetic energy of a center of mass systems which has the two particles of mass m1 and m2 and the rotational radius r1 r2 will have total kinetic energy equal to L square upon 2 mu r square, where L equal to total angular momentum of systems, mu is the reduced mass. In next lecture, we will find out what is the energy of rotational level in a molecule structure. Thank you.